In this video, we're going to look at determining key features of a quadratic function, and that function is going to be given in vertex form. So remember, this here is vertex form, and vertex form is f of x or y equals a times x minus h squared plus k. All right, so here, let's do some quick highlighting. Our a value, we have an h value, and we have our k value. So in this problem, we're going to say that a is equal to 2. H, be careful with h. Remember, it's the opposite of what it looks like. So it looks like minus 3, but h is going to be a positive 3. And k is exactly as it appears, so k will be 4. So again, let's just do some quick highlighting. So we have our a, h, and k. Now, key features of a quadratic function. First thing we want to look at, first key feature is our vertex. And the vertex can be found using hk. All right, so think of it as like your shifts left, right, up, down. But the vertex is our h and k values, which in this case are going to be 3, 4. All right, it's pretty straightforward. Just once you've written out your a, h, and k, you can use the h and k values. And that vertex, I'm going to graph that right away. So we have the point 3, 4, which will be right there. All right, your next key feature is the axis of symmetry, which the formula for that is just x equals h. So for this problem again, we have x is equal to 3. So I'm going to highlight our key features here. So the vertex is 3, 4. The axis of symmetry is x equals 3. Now, your axis of symmetry is going to go right down the middle of your parabola. We don't yet have a parabola drawn here, but the axis of symmetry is going to help us draw that. So I'm going to put a dotted line right here. Your axis of symmetry should always go through your vertex. If it doesn't, there's something wrong. So check your work there. And unless it specifically says to draw the axis of symmetry, a lot of times we don't really show it there because it just kind of gets in the way. But for these problems, it will help us. Now, before we go on to the next key features, which are minimums, maximums, domain, and range, sometimes it is helpful for us to have the rest of our parabola drawn. And to do that, I need some other points. To find those other points, what I like to do, or not what I like to do, what's usually done, is that you need a point either on the left side or the right side of your axis of symmetry. It doesn't really matter which side you choose, whether it's left or right, but what I'm going to do is I'm going to choose the left side, and I'm going to use the value of 2. All right, I'm just going one place to the left. I can go 2 places over. I can use 1. I can use negative 10 if I really wanted to. But the further away, the harder it gets because it's usually off your graph. So pick 1 or 2 places to the left of your vertex in your axis of symmetry. That 2 is going to get plugged into your original function. So I'm going to do 2 times 2 minus 3 squared plus 4. And again, this 2 is my x value. So we have 2 times negative 1 squared plus 4. Sorry, this is y equals. So y is equal to 2 times 1 plus 4. So y is equal to 2 plus 4, and y would be equal to 6. So what that tells me is that when x is 2, y is 6. So I have the point 2, 6 on my graph. So I'm going to plot that there. Now, that point is mirrored on the opposite side of my axis of symmetry. All right, your axis of symmetry cuts your graph in half. The left side and the right side should be identical. So if I have that point 2, 6, I should also have the point 4, 6. So I'm just going to plot that one there. And now I have a rough estimate of what my parabola is going to look like. All right, is it perfect? No, but the points are correct. All right, and then the rest of the parabola is just a quick sketch. Now that I know what my parabola looks like on a graph, it's a little bit easier for me to figure out minimums or maximums, domains, and the range. So the next thing I want to look at is whether there is a minimum or a maximum. So it's another key feature. And here, we want to refer to the vertex. And we want to ask ourselves, is that vertex the lowest point on our graph, or is it the highest point? All right. So in this parabola, that vertex, this vertex right here, is the lowest point on my parabola. So that tells me that I'm going to have a minimum. And the minimum is going to be y equals something. I'm just going to take the y coordinate of the vertex, which in this case, right, we have 3, 4. So we're going to say that the minimum is y equals 4. All right, so minimums and maximums are in reference to your vertex, and then more specifically, the y value of that vertex. If the parabola had been upside down, so let's say you had a parabola that looked like this, the vertex here, that would have been a maximum. All right, but our parabola in this specific problem opens up, so it is a minimum. Next, we're going to look at the domain. Our domain is your x values. All right, my graph is going to continue. It does go up, but the arrows are also going to go off to the right and to the left forever. Any number I can think of, I can plug in for my x value. So my domain is going to be negative infinity to positive infinity. It'll be all real numbers. Domains are usually the easiest part of this. And then my range is going to be based on mostly my minimum or my maximum. It's going to help me. But my range, we're looking at the y values. So in this specific problem, the lowest point is right at 4, and then it's going to keep going up. So my y values are everything here. Right? And then it just keeps going up forever. So my range, the lowest number, the minimum, is 4. The highest number it can be is positive infinity. Remember, infinity symbols are always going to have a parenthesis. 4 is included as part of my graph because we do have 3, 4. So I'm going to use a bracket with the 4. Couple things to keep in mind, and this will make your life a little bit easier. The nice thing about these problems is that the h and k values are used pretty frequently. So your h value is going to be your y value in your vertex, and then it's going to be used again in your axis of symmetry. Your k value, I'm sorry, I said that backwards. Let's go back here. Your h value is your x. I highlighted the wrong one. So x is 3 in your axis of symmetry in your vertex. Your h value will be used each time there. Your k value is your y value for your vertex. It's also going to be used in your minimum or your maximum, and it's going to be used in your range. Okay, so kind of keep that in mind. Notice that each one of these key features, except for the domain, the vertex, the axis of symmetry, the domain, and the range, all used either h or k. All right, the vertex had hk, the axis of symmetry had our h value, and then the minimum or maximum and the range used our k value. So you can always reference back to your a, h, and k to help you fill in each of these. Let's say that you didn't have the graph, you can just use the h and k values to do that. Have a try it. Number 2, give that one a go and see if you're starting to understand this.